So we're going to be solving square root equations. This time we're going to have one radical, and on the other when we get that isolated, we'll end up with something either an x on the other side or an x minus 7 or something, some type of expression involving the variable on the other side. So you're going to have a variable inside the radical and a variable outside the radical, kind of like this. So step 1 is to get the radical isolated. So we want to get this by itself. So that means we need to move the 5 to the other side. So we end up with b minus 5 is equal to the square root of 4b minus 23. Now we need to square both sides. So the part with the radical very simply just becomes what is underneath the square root. The part without the radical, we have to do some multiplication. And so this is going to go back to like we were doing in the last couple of chapters when we were doing solving quadratics. And when we're multiplying, we go from outside in, and we're multiplying b minus 5 to b minus 5. And so b times b is b squared. B times negative 5 is negative 5b. B times negative 5 is a negative 5b. Negative 5 times negative 5 is a positive 25. You combine what can combine. And so that means that when we come back over here on the side, we have b squared minus 10b plus 25. Now, when we're at a point where we need to solve this and solve for b, we have a quadratic equation. You have a couple of options. You can either use quadratic formula, you can solve by factoring, or if you just have the b squared term and no linear term, then you can take the square root of both sides. But that's not going to be very commonly the case in these. Most of the time you're going to end up with something else. And so to do any of the other methods, we need to have all the terms on the same side. So I'm going to move them all to where my b squared is positive. And so that means I'm moving everything to the left in this case. So minus 4b plus 23, minus 4b plus 23. Cancels it out on the right. Leaves me with b squared minus 14b plus 48 equals 0. Now, I want to choose a method of factoring. You could use a quadratic formula. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is one of the methods. But when that term in front of your square term is 1, factoring is usually the quickest method if it works. And so that means we're going to try to go from inside out. So we have the b squared. We have this equal to positive 48. And so we got to think about our factors that will multiply to give me a positive 48b, but yet combine to give me a negative 14. So if I do b and 48b, that doesn't work. If I do 2b and 24b, that's not going to work. If I do 3b and 16b, that's not working. And if they're both going to be positive, then I would create a positive sum. So I need to make sure these are both negative when I'm doing these, by the way. And so if I do negative 4b and negative 12b, that gives me negative 16. I'm getting closer. Do negative 6b and negative 8b. That gives me that negative 14b that I'm looking for. So this is the right steps. So I'm going to use these numbers up here on the chart. And so negative 6b and negative 8b. I am going to look at factoring, so I'm looking what can come out. So if I look at my first column, add b as in both. Look at my second column. They're both 6 and 48 are divisible by 6. My closest sign is negative. So my first factor is b minus 6. My second factor is going to be found by what I'm going to do my rows. So b will divide into both the first row, and negative 8 will divide into my second row, so b minus 8. So now we're going to say each of these expressions equal to 0. And so we have the b minus 6 equals 0, and the b minus 8 equals 0. And when we solve for b, by adding 6 to both sides here, we come up with b is equal to positive 6. On this other one, when we add 8 to both sides, we come up with b is equal to 8. These both could be the solution, but there is a very good possibility of having an extraneous solution. So you always, with these, have to go and check to see if they're extraneous. So let's check for that. And the way you check for extraneous is the same way you've done in other scenarios when we've had to check for extraneous. We plug them both in. So let's find out, is 6 equal to 5 plus the square root of 4 times 6 minus 23. And so is 6 equal to 5 plus 24 minus 23? So is 5 equal to the square root of 1? Or 5 plus the square root of 1 equal to 6. And the square root of 1 is 1, so 5 plus 1, that does equal 6. So this one checks out. Now we're going to check the other one for see if it's extraneous. And so I have 8. Does it equal 5 plus the square root of 4 times 8 minus 23? And so we're trying to figure out, is that equal to each other? So 5 plus 32 minus 23. And so 5 plus the square root of 9. So 5 plus 8, excuse me, 5 plus 3, which is equal to 8. And so both sides match. Therefore, this one checks out as well. So there's actually no extraneous in this solution. Both of them work. Let's do another one. And so on this one, we needed to get to where we have the square root isolated. And so that means we need to move this n over to the other side. So I'm going to add n to both sides. And that gives me n minus 6 is equal to the square root of 2n minus 4. We square both sides. On the right hand side, that just cancels off the square root, leaving me 2n minus 4. On the left hand side, we're using that box, and we're going to try to see, we're going from outside in, and we have n minus 6, and so that gives me n squared, negative 6n, negative 6n, and 36. And so that gives me n squared minus 12n plus 36. I need to move my right hand side over to the left. And so I need to move the 2n by subtracting 2n. And I need to move the 4 by adding 4. And that gives me n squared minus 14n plus 40 equals 0. We need to check and we need to factor this out, so we're going to go from inside out. So n squared and 40 here. And so I'm looking for the factors of 40 n squared that will add to give me a negative 14. So negative 1n and negative 40n. Does it work? Negative 2n, negative 20n. That's not going to work. Negative 3, does it work? Negative 4n, negative 10n. That does work, so I'm going to go ahead and fill that in. And look at factoring out my first column, n minus, and then the second column, negative 10. First row, n divides into both, and a 4 divides into both of the second ones. It's not n, and the closest sign was negative. And so my two factors are n minus 4 and n minus 10. And just like we did on the last one, we're going to set it equal to 0. And so each of the factors get set equal to 0. And we're going to solve. So n minus 4 equals 0. That gives me positive 4. n minus 10 equals 0. That gives me n equals positive 10. And when I check for extraneous, I'm going to plug both of those in to check. And so negative 6, does that equal the square root of 4 times 2? Minus 4. And negative 6. Oh, and then minus 4 at the end. So 8 minus 4 is going to be the square root of 4 minus 4. And then we're going to take and square root of 4 is 2 minus 4. Gives me a negative 2. And so that does not equal. So that's an extraneous solution. So let's check the other one. Negative 6. Does that equal 2 square root, or 2 times 10 minus 4 minus 10? And so let's find out. 2 times 10 is 20 minus 4 minus 10. So square root of 16 minus 4, or excuse me, minus 10. And so 4 minus 10 is that negative 6. So this one checks out. And so my solution on this one is n equals negative 6. That is the only solution I have. So I want y'all to work this last question. A plus 5 is equal to the square root of 5a plus 61. When you work it out, you should have come up with two solutions that you had to check, negative 9 and positive 4. And when you check both solutions, you find out the only one that works is that positive 4. So that is the only solution.